Okay, so question 30 right here. For question 30, we have another irrational equation. Definitely could be factored. So you can see that on in the numerator you have x minus 5, x plus 4, and then you have x plus 2, x minus 2. Okay, x plus 2 and x minus 2. Now, well, let me show you a different way of doing this. We did the graphing for question 29, and let me give you the sign chart alternative for this one. And this might be a good idea to do a sign chart because you have so many factors, and I mean, you can still make the graph, but life could be a little bit hectic in this way. So let's go ahead and do a sign chart. Now, I think there was a previous question earlier that I used sign chart to solve it, and I said this earlier already. The primary problem with using a sign chart is that do you know how to construct a sign chart properly? Okay, now we will write down all the factors on the left. Okay, we will write down all the factors on the left. And then we have the overall or the function. Okay. Now, this is the beginning, okay, part. So make this the negative infinity, okay, and then make the other end of it positive infinity. And let me go ahead, change the color of the top line. Oops, nope, I'm not duplicating. I want to change the color of the top line right here. Now, that is actually a number line. Make sure you look at this as a number line. And now for me, I have the luxury to use different colors, but for you, you probably will just have a pencil or pen, a pencil actually, since you'll be doing a Scantron exam. So just make sure that you use your notation system well. Now we have two vertical asymptotes, meaning that there are two x values that cannot be valid. We have a -2, and we have +2. Oh, sorry, should be both open circle. And to make the sign chart more visible, okay, I'm going to draw a pair of dashed lines to indicate my vertical asymptote, basically like the actual graph. And then we have the x-intercepts. We look at the numerator to look at my x-intercepts. My x-intercepts would be at -4 and +5. Now, I'm going to use a pair of solid lines in this case because they are included in the solution set. Okay, they are included in the solution set. So what we're dealing with right here is that we have a lot of signs to fill in. Now, just make sure that you know how to make this a much easier process. All we care is just a bunch of signs. So let's say for the first one, x minus 5. Well, apparently, if you want to get it positive, you have to make it bigger than 5. If it's less than 5, it's negative. Okay. For x plus 4, it will be positive if it's greater than -4. But if it's less than -4, then it becomes negative. For x plus 2, well, it is positive if x is bigger than -2. But if it's less than -2, it's going to be overall negative. And then for x minus 2, it will be positive if the x value it's bigger than 2, but it will be negative if it is less than 2. Okay, so now we have all the signs written out. Now, just make sure that you understand what's the conclusion process. How do you make your conclusions? So basically, we are having all these factors with different signs. We are multiplying, dividing, and we're just looking at the very simple idea that you learned back in middle school. Negative times negative is positive. Okay, negative times a positive, it's still negative. So you can just think about, well, all these negatives and positives, they are multiplying together, and you look at it vertically. Okay, you look at it vertically. So for the first row, first column right here, you have 4 negatives. They have all multiplying or dividing each other. So you would end up having a positive sign. And then for the second column right here, you have an odd number of negatives. So that means it would end up being negative. 2 negative signs. So positive. Only a single negative sign right here, negative. And then you have a positive right here. Okay. So you want the part of the rational function that's less than or equal to 0. Okay, so that means you definitely want the negative part and also the 0. So therefore, the solution would be -4 to -2, including the -4, excluding the -2, since -2 is the vertical asymptote. Union 2 to 5, not including 2, but including 5. So that's a way to solve this rational equation or inequality. Okay, if you need to make a graph, you could. I can also make a, well, with the sign chart, I think we can also make a graph pretty easily. We have 2 vertical asymptotes, one at -2, the other one at 2. And then we have a horizontal asymptote. In this case, since the power of both numerator and the denominator they are the same. So just look at the leading coefficient, which is 1/1. So it's 1. You can look at the intercepts. So we have a y-intercept at 5, and then we have 2 x-intercepts. One at x equals to 5. The other one is x equals to -4. So if you want to draw the graph, that's pretty straightforward. It's going to be something like this. Okay, it's going to be something like this. It's going to be something like this. So if you make the graph properly, you can also get the same conclusion. Okay, the same solution set for this inequality. Okay, again, when you're solving for inequality, you're just looking at what x value or x values that would make the statement, in this case, the inequality statement, true. Okay, you are just trying to find out what makes it true.